Imagine reaching the end of space. You fly past the last galaxy and find a wall with absolutely nothing behind it. There is just one problem. Physics does not know whether that wall exists. The universe may be infinite. It may also be finite, wrapped around itself, and completely edgeless. So how can something be finite without having an end? First, we need to separate the universe from the observable universe. The universe is everything. The observable universe is only the region whose light has had enough time to reach you. It is at least 93 billion light-years across, even though the universe is about 13.8 billion years old. The light was traveling while space expanded, so its source is now much farther away. But the glowing sphere around us is not a physical bubble. There is no glass at its edge, no warning sign, no cosmic border guard. An observer in another galaxy would have a different observable sphere centered on them. Their horizon would include places we cannot see and exclude places visible to us. The edge moves with the observer, so it cannot be the end of everything. Now we reach the first serious possibility. Space may simply continue forever. Travel in one direction and there is always more room ahead, perhaps including regions whose light will never reach us. Measurements of the cosmic microwave background show that space is extremely close to geometrically flat. On enormous scales, parallel lines behave almost as they do on a sheet of paper. An ordinary flat plane can continue forever. Case closed? Not even close. Take a flat sheet of paper and imagine joining opposite edges. You can create a looping world. A traveler moving forward could eventually return from behind without ever hitting a boundary. The usual two-dimensional example is the surface of Earth. It has a finite area, but an ant can walk forever without finding an edge. A finite three-dimensional universe could behave in a related, much stranger way. After light completed a journey around the cosmos, you might eventually see the Milky Way from behind, possibly more than once. Scientists have searched the oldest light for repeated patterns that could reveal this kind of wraparound topology. So far, no convincing pattern is shown that the universe loops back on itself. But that does not prove it is infinite. The loop may simply be larger than the entire region we can observe. Pause there. If the universe has no edge, what is it expanding into? Maybe nothing. Expansion does not require galaxies to fly through space into an empty room outside the universe. The distances inside space increase. Asking what space expands into may be like asking what lies north of the North Pole. The grammar works, the geometry may not. And even if space continues forever, your reachable universe does not. Because cosmic expansion is accelerating, distant galaxies are crossing a horizon beyond which signals sent today will never reach us. Eventually, most galaxies outside our local neighborhood will fade from view, not because they fall over an edge, because the space between us grows too quickly for their new light to overcome it. So, does space ever end? The honest answer is that we do not know. It may be infinite, it may be finite and looped, but every model that fits our observations delivers the same unsettling result. You will never reach a wall at the end of the universe. The true boundary is not where space stops. It is where information can no longer reach you. Would you rather live in an infinite universe or one that eventually brings you back home? Tell me which possibility frightens you more.